Today we're going to cover section 1.8 of the BJU Press PreAlgebra textbook. We're going to learn about scientific notation. So scientific notation is just expressing a number as a product of a number between 1 and 10 and then a power of a 10. So let's look at this number. This is obviously a really large number, and because of that, we can write it a more simple way using scientific notation. The first thing we want to do is we want to go ahead and move our decimal in order to make a number between 1 and 10. So we'd have to move it 1, 2, 3, 4, 5, 6, 7 times in order to get a number between 1 and 10. So the number that we have to move the decimal, that is what's going to become our power of 10. So we have 9.3 times 10 to the 7th. And the reason that is going to be positive 7 is because if we were to reverse this and we were to actually do 9.3 times 10 to the 7th, we would want this number to get bigger. So that means that this exponent needs to be positive. Let's look at this number, 0.000045. So this number is really tiny. The steps start off the same. The first thing you want to do is you want to move the decimal until you have a number between 1 and 5. So we actually have to move it 1, 2, 3, 4, 5 times in order to get a number between 1 and 10. And that becomes our exponent, or our power of 10. This time we have a negative exponent, and the reason why is because if we were to reverse this, we would want our number, when we multiplied by 10 to the negative 5, we would want it to get smaller because that was the number that we started with. So let's start with an example. Let's write the following number in scientific notation. You should have gotten 1.67 times 10 to the 6th. Let's try this one. You should have gotten 5.9 times 10 to the negative 4. So if we want to change scientific notation back to standard form, the exponent is going to tell us how many places to move the decimal. So for this one, we want to move our decimal point 5 times. And since it's a positive 5, we want our number to get bigger. So we're going to move it 5 times to the right. We place zeros anytime that we have to annex a 0. So here's 1, 1, 2. We have 3, 4, 5. So we have 3 trailing zeros. 8.4 times 10 to the negative 3. This time we have to move our decimal to the left to make our number smaller. So 1, 2, 3. So let's talk about very small numbers and how to name them. So we have micro, which means a millionth of a number, and it's 10 to the negative 6. Nano means billionth, and it's 10 to the negative 9. Pico means trillionth, and it's 10 to the negative 12. We have femto, which is quadrillionth, and it's 10 to the negative 15. And atto is the quintillionth, and it's 10 to the negative 18. Then we have very large numbers. We have giga, which is a billion, that's 10 to the 9th. We have tera, that's trillion, it's 10 to the 12th. We have peta, which is quadrillion, it's 10 to the 15th. And exa is quintillion, it's 10 to the 18th. So last example, let's write the following distances in scientific notation. We have the speed of light, and it's about 186,000 miles per second. So we want to write that in scientific notation. So it becomes 1.86 times 10 to the 5th. So again, we moved our decimal 1, 2, 3, 4, 5. That's how we got our first number, 1.86. And then that 5 became our exponent, and it's positive 5 because our original number was a bigger number. Let's do another example. example. We have 3.6 nanometers, and a nanometer is 1/billionth of a meter. So if you look at that chart that you wrote down, remember billionth was 10 to the negative 9. So we've got 3.6 times 10 to the negative 9.